Hello guys, how to differentiate among BJT bipolar junction transistor and FET and MOSFET transistor. FET, it's a family, it's a field effect transistor. How to test all of them on the board, on the electronic board, and separately by separating it from the board using oscilloscope or and multimeter or avometer. Follow me in this video to know how to do this. This image will discuss all the story of these transistors. Okay, so we have these symbols in the schematic diagram or circuit diagram. This for the BJT or bipolar junction transistor, and this for the field effect transistor. There is some comparison. This arrow, if it's coming from the base to emitter, so it's NBN transistor. If the reverse, this arrow reversed, so it will be BNB transistor. So this is the base, this is the collector, and this is the emitter. In all times, this base, collector, emitter. While in the FET transistor, this is the base is gate here, and here's the source, and here's the drain. And the arrow in the gate, it's not on the this arm. Okay, so it may be like this or in the reverse. So let's know the BJT, how to test it in the separately from out of the electronic board. You will lose it and separate it and use the multimeter to measure it. So here we have, this is NBN junction, so this symbol NBN, so this symbol. Okay, so if I put the prop of the positive here, of the positive of the multimeter, the red one, the positive one, the red one in the hole, in the B, and put the other, which is the common black one, in the N. So there will be forward junction, which means small resistance forward, or the voltage will be 0.7. Okay, so and the other way here, if the red one, the red prop here, and the black one here, there will also be small junction, but it will be greater than this one, but it's still small. Okay, so this, if I reverse it, there will be open circuit or higher resistance. If I put the black one here and the other red one in this direction, there will be high resistance or maybe open direction. No current, no signal. Okay, no reading. And the same way, this one is BNB. So this is the base, the emitter, the collector. Here I will put the black one in the middle, in the base. Okay, and I will repeat the test. I will find here small resistance, and in the other with the collector small resistance. And if I reverse the props of the multimeter, which means this will be red prop, there will be if I in the circuit, in the electronic board, there will be greater resistance. If it's outer of the board separated, it will go open circuit. Okay, this is the what is here, because this one is BNB and this one NBN. Let's know where the base, where the emitter, where is the collector. If I have this shape of the BJT, so here in the upper one, in the upper side, there will be in the middle the base. In the middle is the base, while in the right of it, if I sit here, So in the right the collector and the left emitter. While here there the gate at the first in the left, and then we have the drain which upstairs and the source which is the down. So this is the source and this is the drain. So then we have gate, drain and source. If this BJT, there will be also the shape, the same shape. Here will be the base. At the left side, the base. And then we have the collector. And here we have the down, which is the emitter. Base, collector, emitter. Note, that's here the ventilation. So you have the other face. The face of the ventilation عشان تبقى عارف يعني هنا الليفت لما يكون الفنتليشن in the other side. Okay, here we have the symbol. This is the symbol of FET, also another symbol. You can use this one or this one. We have the here the difference between BJT, FET, MOSFET. Device type, the current controlled. The other two is voltage controlled. This is bipolar, this is unipolar. Okay, terminals not interchangeable. Terminals interchangeable. يبقى هنا not interchangeable, interchangeable. هنا I can interchange terminals. Operational modes, no modes. Depletion mode only, both modes, depletion and no modes. Output resistance, moderate, low, very low في الموسفيت. Operational speed low, moderate, high. Because of this, these two types can work as electronic switch. This one especially, this MOSFET is very important to know. We can use it as electronic switch MOSFET because it's high speed in operation. Noise high, low. So now why we are using the equation? Why to know the equations of this? If you need to calculate, use these equations and use the circuit diagram, you can test the transistor on the board, on the electronic board, without removing it. If you are clever in computations and calculating these equations and know how many voltage here, how many current here, so you can detect the current here and the voltage here. And by this, if you find this okay, so this transistor is okay. So it's very simple. So where we have here three equations, three important equations, which I emitter equals IC plus LI base. IC is coming all time in this direction and the I base in this direction, and IE in this direction. Beta, which is the gain factor. When we by the way, these transistors can work as switch or amplifier. Who is amplifier? BJT is a good amplifier, while FET transistor or MOSFET working very good as switch, electronic switch. Okay, so here we have beta. If we have great beta, we have great amplification. How to calculate beta? I collector over I base. Okay, so alpha is I collector over I emitter. So I have three equations. From these three equations, I can obtain this equation and this equation, because this is a function of alpha, and I can get alpha on the other side and beta on the other side. So from these three equations, I can get this equation. Okay, so this will help me know that, because this is current driven. So here I am measure current. While here we are this voltage control. A FET transistor is voltage control. So here I speak in voltage. So the VDD is the VDD equal this voltage plus this voltage. So how to calculate VGS, this one, from the gate to the source? This voltage, which is this voltage, which is VR2. It's very easy. I calculate this current. This current is this one. I neglect this current because I am going to use voltage control. So here I neglect the current here. So IR2 equals IR1. Okay, this one. So I times R1 times R2 equals VDD. So VDD over R1 plus R2 times R2 is VG, which is this voltage, VG. How to calculate VGS? I VG minus VS, VG minus VS. It's very simple. So VGS equals VG minus VS. Okay, VG minus VS. This equation. Okay, and this VS, which is IDR2 or IS, sorry, IDRS, because ID this one is equal this one. Okay, okay, ID equals VS over S. But by these equations I can measure this voltage here, and using the oscilloscope I can test this voltage, AC voltage or DC voltage, and I can decide if this transistor is working good or damaged. The same way I can use multimeter or oscilloscope. Sorry, here I'm using multimeter to calculate or test or examine how much I see here, how much I base, how much I E. And from these equations I can see how much or how is this transistor is good, working good, or it's damaged, not working, open circuit or short circuit. Okay, if you have any question, don't hesitate to ask me and I will reply you as soon as possible. With you, Usama Gandur. Please subscribe to the channel and share the video with others.